I hope everybody is doing well today and feeling secure because the asteroid in question that I talked about passed by or is passing by at a distance of over 1 million miles, which is still an uncomfortably close call given the size of the asteroid that we're talking about. But still, interesting stuff and something that I thought it would be very timely to talk to everybody about this and just how woefully unprepared our civilization is for anything like this, any sort of danger like this. And I'm glad that everybody can hear me. That's a great thing. I'm going to try to keep this microphone positioned in just the right place, so the lack of a pop filter doesn't mess things up too much. I'm getting better and better at traveling light as time goes on. And yeah, got the glasses off still because I'm completing another video today where I'm actually without any glasses of any kind, just because I think the glasses detract a little bit from credibility given what I'm talking about in this particular video. Not this one, but another one. So I just don't want, yeah, and I'll have them back. Don't worry. The glasses will be back because that's part of my trademark. But nevertheless, I'm going to be talking about some very controversial stuff. So I want to make certain that it's something that it's in the midst of passing us right now, actually going by us at this moment. Space.com did an update on it about 4 hours ago. Just 1 second, and I can get you some information on it right now. That is the DART mission. Bear with me for just 1 second, and we'll be talking about that as well. And unfortunately, it was delayed. The DART mission being our mission to try to deflect an asteroid. Anyway, the asteroid, which is called FO32, is passing us at a speed of 124,000 kilometers per hour, which is unusually fast for something. And this is relative to us, of course, but still unusually fast indeed, given what we're going to be, given what usually passes us by. Yeah, and unfortunately, DART will not be launching this year. The November launch date was delayed until 2022. This is according to a recent um, notification that I got, and or rather a recent notification from space.com. It really sucks because the ESA was supposed to be collaborating with NASA on this incredibly important mission, the first mission designed to tell us whether or not an asteroid could be easily deflected away from colliding with the Earth. And the ESA mission was canceled or delayed and now is going to be replaced by something called HERA. The ESA part of it was to send a probe to the asteroid, or rather two asteroids, a smaller one orbiting a larger one, and then observe both of them, their composition, and how likely was a collision, or rather what we intended to hit the smaller asteroid with, what it would be likely to do to that asteroid, what our predictions would be, and then we slam into it with a kinetic penetrator, which is the DART mission, and that's into the smaller asteroid. And we're very fortunate to have two asteroids, one orbiting the other, because we can see what DART does, the effect that it has on the smaller asteroid versus the larger one, how much it adjusts its orbit, and then that can give us a good idea of what a kinetic penetrator is going to do to an asteroid. I may or may not go to see DART in person since it's going to be launched by a Falcon 9. I may have an interest in going to see it. I don't live too far away, so it is possible. Once again, I still have a lot of work to do, and obviously, and I want to apologize for my lousy live stream the last time. I still have a lot of work to do when it comes to telephoto and giving better, quality visuals. Although the plume at the end of it was pretty awesome, and I didn't need anything for that. I just needed to rip the cell phone off the stand and show you guys how incredible that was. It was unreal. So I did enjoy that. Do I think Boeing is going to get their stuff together? I think eventually even Boeing isn't that incompetent. They've been delaying for years and years. And the reason I believe that now is because the green run went so well. It only had to go for 4 minutes for Boeing to get the information that they needed in order to get the data that they required. However, they got a lot more than that. They went the full duration of the burn to get all the information that they needed on engine gimbling and that sort of thing. I covered that pretty thoroughly in a video I just released, so I'm not going to talk a lot more about that, but it gave me a greater sense of confidence that that SLS may launch this year, and that's Artemis 1, of course. Okay, so let's see here. I am going to I'm flipping over to the questions and answers. But just as a reminder, my Patreon supporters always have access to the Discord server and can send their own questions through that. So I try to pay attention to both as best as I can. One of these days, my channel's going to be big enough to where I can have some assistance. I already have some people who help me out very generously online, but it'd be nice to have somebody with me. So we'll see. We'll see what happens. Oh, shout out to Colorado. Shout out to Colorado, my home state, my alma mater, CU, and so many fantastic things that they do in the world of space flight. Really a wonderful thing. So our near Earth orbit satellite is going to be sent to the far side of the sun to help us detect these things in time. That what Bruden 62, that was the original intention, actually. The European Space Agency was going to launch some objects called Sentinel that were supposed to get rid of the sun's glare and watch any asteroids coming in. And then they got canceled, didn't they? We just have no concern about these things, no fear, even though there was a meteor that exploded over New Hampshire, or was it Vermont? I think it was Vermont, actually, that blew up with 60 tons worth of high explosives or something along those lines not that long ago. So that's we get constant warnings all the time, and there is a meteor that blew up over the United Kingdom not that long ago, and it really doesn't take a whole lot of effort as far as that's concerned. And as far as Super Heavy is concerned, my understanding with this Super Heavy is that it's not going to fly at all. That it's being used for to determine what sort of stress loads it can take, weight, that sort of thing. That this is kind of more of a mock-up Super Heavy, that this one isn't going to fly, that the next version is going to. So that's one of the reasons why I haven't been covering it all that thoroughly, just because I tend to cover things more when they take off or when they do a static fire before I do any reporting on it, just because there's so many people who are reporting on that right now and doing a good job of it. So I don't need to be one of the people that do that. It seems Ouija Lego says it seems that we'll need to have a horrific tragedy or natural disaster result as a result of an impact. I agree. And it seems to be a recurring problem. No one takes these things seriously until it happens, like 9/11. Yep. Or huge tsunamis, for example, that sort of thing. So anyway, yeah, and we could look, from Mars. That was an answer to a question there. That could be another possibility. But yeah, I would think that that something like that is going to happen. And then what are the options? Blow it up, redirect it. That's something Bruden 62 is asking about. Would it be a nuclear option? That sort of thing. Yeah, there's a lot of things that we could do, but I'm gonna play a little game with you right now. It's called Let's Hit the Earth with an Asteroid. And there's something called the Earth Impact Effects Program that's put out by some organization in the UK. And so it's very, very precise. And I'd like us to be realistic about this. Let's not have, something the size of Jupiter crashing into the Earth or something like that. Let's do something, modest. Let's come up with something kind of cool. So first of all, let's see how far away are we from the impact. And I'm going to determine that one right now. I'm going to say, let's say we're 30 kilometers away from the impact. Okay. Now let's say how big. Let's have some votes here. How big do we want the object to be that's colliding with the Earth to give an idea of what it's going to create? And once again, don't make it ridiculously huge. Any votes on that as to how big we want this thing to be? And I'm going to live stream Q&A as well. 5 kilometers, 50, any of these, by the way, would be way too huge. If 50 kilometers, 5 kilometers would create an extinction level event. Let's do it a little bit smaller. And once again, we're looking at size. We're 69 kilometers. 600 meters. There's a good one. 600 meters. Let's do that one. Just over half a kilometer, obviously. So let's go 600 meters. And by the way, there's a link in the description that shows just how many objects that are 600 meters in size or larger that we are unaware of their location. We have no idea where these near Earth objects are, but we calculate that there are quite a few of them that we have yet to detect. So 600 meters. Now, what do we want it to be made out of? Do we want it to be made out of ice, porous rock, dense rock, or iron? Those are our 4 choices. What do we want our asteroid to be made out of? So let's see here. Iron. Okay, I'm going to go with iron. Iron asteroids are relatively common, although C-class asteroids are more likely, but still the one that created Meteor Crater in Arizona was made out of iron. So we're going to stick with iron. Now, the impact velocity of your typical asteroid is about 17 kilometers per second. Now, just so you know, comets come in at 51 kilometers per second, way, way faster from the Oort cloud and from the outer reaches of the solar system. So if we took it to 88 kilometers per second, it would be crazy. Let's keep it kind of within the normal range of an asteroid just to keep this realistic. 17 kilometers per second. Now, the impact angle matters as well. If it comes in at 90 degrees straight down, then it's good. Yeah, we could do a Muamua at 87.8, but it was an interstellar asteroid, and that's why it was going so crazy fast. But, well, okay, why not? Let's say it was a Muamua, but put it at 87 kilometers per second. Oh my God, this is going to be terrible. Okay, and then the impact angle, if it's a Muamua, is going to be coming in at a much steeper angle. So let's say maybe 70 degrees, something along those lines. And let's say it hits sedimentary rock. Okay. So here we go, guys, and this is going to be rough, most probably. Okay, so just brought it up. Here's all the stuff that we brought up. It was made out of iron. Okay, 8.18 times 10 to the 5th power megatons worth of TNT, 800,000 megatons. 800,000 megatons. That's what we're looking at in terms of the explosion. By the way, the average, the interval between impacts like this occur every 3 to 4 million years. So we're not talking about, all the time then. But at the same time, we're not talking about, every 60 million years like the dinosaurs. With that having been kept, with that having been mentioned, it would have a crater that is 22.2 kilometers in diameter. That's the transient crater as it was exploding, and then its final crater would be 33.4 kilometers in diameter with a depth of 851 meters. And at the distance we're at, we would be very, very, very dead. Clothing ignites, most of the body suffers third-degree burns, newspaper ignites, plywood flames, deciduous trees ignite, grass ignites. It would have an effect of 8.6, an earthquake of 8.6 on the Richter scale. The destruction at a distance of 30 kilometers would be beyond belief. All masonry frame structures with their foundations destroyed, serious damage to dams, dikes, embankments, large landslides, water thrown on the banks of canals, rivers, and lakes, sand and mud shifted horizontally on beaches and flat land. Even train rails would be bent. As a result, underground pipelines completely out of service, and the ejecta would arrive about 1.31 minutes after the impact. And the ejecta thickness would be 80.1 meters worth of stuff falling down on you. 139 decibels would be the sound generated by the explosion at that distance. The wind velocity would be 2,400 meters per second, or over 5,300 miles per hour. At the distance we're talking about. So once again, we kind of took things to the extreme there, but keep in mind, that wasn't the biggest asteroid that's in our vicinity, not even close. We had it come in at a crazy speed. I mean, and a speed, typical of interstellar objects, but still. And yet, it probably wouldn't create an extinction level event, but the destruction would have been colossal. It would have been, utterly devastating. And you can scale this thing down. Oh, this is from the Imperial College in London, by the way. I knew I was missing that. And that's not a very big one. The Tunguska event, to answer your question, was between 15 and 20 megatons, and probably created by a comet. And the reason we believe that is because it left no appreciable crater. So that's our assumptions as far as that's concerned. And in that place has been examined again and again and again by experts, and not a lot of debris found to suggest that any kind of asteroid exploded or air bursted over that area. But that is the current theory, is that it air bursted, therefore not creating much of a crater, and at the same time not not leaving a lot of debris, because ice tends to melt, and that's what comets tend to be made out of. So that's what we ended up with. So that was our little exercise in asteroid destruction. I hope you guys enjoyed that. Yeah, if it hit at 90 degrees, that would make it even worse. What would be the delta V needed to move something like that out of the way? That would be crazy. It would take a lot of effort. And, the delta V, once again, is entirely dependent on how much of an advance notice we get, how much of a warning we get. It is really, really important that we detect these things as early as possible. Now, the big problem, associated with these things, of course, is, we're just not putting enough effort into just detecting them. And then when we do detect them, a lot of times we only have a few years worth of warning. The average comet, for example, is not detected until it's, maybe 2 or 3 years away from Earth. And given that it takes us a minimum of 5 years to put a mission together, and that's if we do it really, really, really fast. Any mission sent to stop a comet coming in with our current level of detection simply would not happen. And the only realistic way to stop this is to be prepared for it, to have a system in place to stop it before we actually do anything about it. And by the way, we got a lot of people watching. I'll do another one of these little things just for fun. For the people who missed it. But for folks who are watching, please please subscribe if you haven't already. I do appreciate we have almost 400 people watching. And, at the same time, traveling to these places, there's been a lot of support that's been given to me already. I do appreciate everything that's been done. And, anything I'm stuck here as a result of my car being broken down. That's my problem, not yours. But, another reason that I do live streams is to see if I can get any support. But once again, if you guys just like and subscribe, I will be a happy person indeed. So thank you no matter what. And that's all I'm going to say about that. So, so once discovered, what would be the GoFundMe goal need be to stop it? Says Brood 62. It would be billions of dollars that we would need to invest in order to stop it. And there are lots of ways. Oh wow, Foom, my God. Foom just made a Foom asteroid impact level super chat. Thank you so much. Oh my God. Thank you so much. I don't know what else to say, but I really do appreciate it. So, one of the reasons that I just wanted to go through that exercise is indicate to you that that wasn't a very big asteroid. That wasn't nearly as big as the one that wiped out the dinosaurs. And yet, look at what happened. Look how huge. We're talking hundreds of thousands or over 100,000 megatons worth of, explosive power from this asteroid. That is mind-boggling. Thank you so much, Easy BZ. Thanks. Wow, getting this going. I do appreciate that. You guys are the best. And like I say, this is going to a good cause. Because my next goal, by the way, is to watch SN15 take off. Not SN11, but SN15, because that's going to be the one with all the new changes, all the new modifications made, that sort of thing. So I want to go back to Boca and I want to get some decent equipment this time and film the damn thing. So that's my objective as far as that's concerned. And also, of course, to film SN15 for you guys before it takes off at a close range, maybe live stream from the launch pad again, like I did before, that sort of thing. So that's what we're looking to accomplish with everything that I do. So thank you very much. Chris coming in with 25 quid as always. Thank you so much. You are amazing, Chris, coming in and helping me out as much as you do. I'm so moved. Thank you. Thank you. All right, so we'll keep things going. Surprise and land SN15 on the moon. It'd be more like crash it into the moon would be my guess. Wow, Foom, thank you so much. Jeez, Foom, thank you. I don't know what to say. Thanks. All right. But yeah, and of course, this SN15 could not crash into the moon, even if you threw the vacuum raptors onto it. It would be able to just barely achieve, maybe suborbital flight, even with all 6 engines on it going full power. And that's if you stripped off all of the, if it was carrying no cargo, if you stripped off all of the heat shield, all of that kind of stuff. Maybe you could get it up into suborbital space, something along those lines. Thank you so much, Mr. Dot, is that right? Boy, I can't see it that clearly. And I don't want to scare people getting too much of a close-up, but thank you. So yeah, things are, getting to the moon with SN15 would be impossible without the Super Heavy. And even with the Super Heavy, we would still need a refueling using the SpaceX method versus the Boeing method. Yes, that's true. I just experiment with stuff and sometimes it blows up in my face and sometimes it works. What I can say is the times that I have blown things up on camera, it's usually gone pretty well. I've done okay with destroying things on camera, but in terms of producing nice images, there are people who do it way better than me. So second stage could do orbit of strip right down, but couldn't get it back at all. Yeah, that's right. That's right. It would be something else. So let's talk about the ways that we could stop it. DART is the current method that we're looking at right now that will be launched in 2022. And by the way, in spite of the delay, oh, wow, thank you so much, Dimes. Okay, so the DART mission, in spite of the fact that it's been delayed, it's still going to arrive at its target on time because of the motion of the objects in question. It will still get there to these two asteroids, one smaller one orbiting the larger one. And then it's going to take some readings. It actually has a small sat made by the Italian space company on board, and a space corporation, when I say Italian space agency on board, and it's going to be examining the asteroid, looking at its composition, both pre and post impact, to determine, how much we adjust the asteroid's path. And this is the smaller asteroid orbiting the larger one. How much do we adjust it with a kinetic penetrator? And is this the best way for us to stop an asteroid? That is the current plan. However, here's the problem. If you're going to divert an asteroid with a kinetic penetrator, that means you need to have that mission ready to go, and at least one, and probably I would say two or three, just to have, proper redundancy built into it, given how important it would be for us to stop something like this. So, wow. Oh, thank you very much. I keep interrupting myself, but thank you very much, Mr. I think it's Darmo. And if I'm mispronouncing, I'm sorry, but we'll keep it going. So yeah, if you're going to have a kinetic penetrator mission to stop an asteroid, it has to be ready to go, primed, to launch within, a month's notice or something, because of the lack of time that we have in terms of advance notice. We just, need to have something like that ready to go. I'm not in favor of that, to be honest. I would prefer an orbiting network of reflectors that would concentrate, either lasers or some sort of concentrated sunlight, that would redirect an asteroid. Now, photons impacting an asteroid don't make a huge difference, but if you keep high energy photons and a lot of energy focused on an asteroid for a long enough period of time, eventually it's going to shift its orbit out of the way. And you can also use those things for a variety of other purposes. You can use an orbiting network of lasers or, solar reflectors to send out the Breakthrough Starshot initiative, to send light sail probes out to out to. Thank you, Foom. Wow, you just keep going. Thank you so much. I don't know what to say. So Breakthrough Starshot to send probes out to Proxima Centauri, an idea that was mostly put together by Avi Loeb, Dr. Avi Loeb, who is more famous because of his association with Oumuamua and the theories of its artificial origin. And I'm giving you a few little hints about what I might be talking about in my next episode, because some recent information came out about Oumuamua, another new theory, that sort of thing, which needs to be addressed. Mike, thank you so much. Guy, thank you. Wow. Deeply appreciate the support. Thank you so much. So anyway, that I'm, in response to some of these new theories that are coming out about Oumuamua, I am putting out a new episode today. I'll be releasing it in a few hours. I've done a lot of work already, and it's based on a book written by Dr. Loeb and released just a couple of months ago that I burned through. I just couldn't stop reading this thing during my time here in Mississippi and Louisiana, and the evidence is overwhelming, in my opinion, just completely overwhelming. But I'm not going to give away more than that. But it's kind of connected to what we're talking about. We're talking about an object entering our solar system at a high rate of speed, kind of like an asteroid that might crash into us, that sort of thing. So yeah, we got new stuff coming, guys, and you're gonna like it. I think you're gonna like it, including, by the way, the first artist conception of what Oumuamua probably looks like, in the opinion of myself, Dr. Loeb, and a lot of other people. This is going to be neat. So anyway, all of that's going to be there. Why will only elite scientists be the only ones who are informed should an asteroid be discovered if we can't stop it? Apophis has a keyhole location of concern that we are waiting for. Bruden 62, I would say that there's a good chance of that, because if there's nothing we can do to stop it, the panic associated with something like that would be horrific, utterly horrific. It would throw our planet into utter chaos, and so we would spend, the last years of our existence going crazy. Not a good way for our civilization to end. And of course, there's a possibility that we could survive it, if we made plans ahead of time, but only a small percentage of the population, and everybody else would die. And that is a grim future to look forward to. And I think that, probably it would be kept secret, to the best of our ability, until eventually it had to be released. That's a grim thing, a thing I don't want to see the human species face, but it could happen. Like I say, to smaller extents, it already has happened. If the Tunguska event had happened right over New York or something, I think our view of comets and asteroids hitting the Earth would be totally different, given that it would have completely leveled the entire city. Our view of the whole thing would be completely different. But guess what? It hit somewhere in the middle of Siberia where there was nobody. As a matter of fact, the Soviets didn't even send an expedition until about 10 years later. So, it's just something that didn't attract a great deal of attention, even though it had worldwide effects. It created luminosity in the sky, whereby you could read books in the middle of the night in London. Crazy things associated with this impact in Tunguska. Amazing stuff. The Sodom and Gomorrah thing. Yeah, that's possible. Entirely possible that it was a meteor impact. There are lots of cataclysms that have happened in the history of this of our species that could be attached to an asteroid impact or a comet impact, and we just didn't understand it back then. We didn't have the scientific knowledge to understand what had happened, and so we associated it with something else, with an earthquake, with a volcano, with the hand of God. Who knows? Who knows what it was? So anyway, but what we've been talking about, for those of you who got here late, has just been the asteroid that is passing us today at a high rate of speed. Something that, if it did collide with us, which it's not going to, it's a fair distance away, but if it did collide with us, the damage would be cataclysmic. It would be awful. And so we're talking about ways of dealing with it. And as I said, my preferred way is with a satellite network of lasers or solar reflectors used to bombard the asteroid with photons, high energy photons, which don't provide a great deal of deflection. But if you keep doing it year after year, eventually it's going to push it away, especially if it's a comet, because it will heat up the comet and cause cometary outgassing, which is going to push the comet onto a different trajectory. So that makes a big difference. Thank you so much for the super chat, by the way. Let me have a look real quick. Oh, gravity tractors. Yes, we can talk about that too. Thank you so much. Boy, I'm sorry, I can't read your name. Is it Revloon or yeah, I think it is, or Revtune. I had something along those. Thank you so much for the super chat. Gravity tractors. Let's talk about that. So gravity tractors, for those of you who don't know what that is, once again, it's a very, very, minimalist way of deflecting an asteroid. What you do is you take a spacecraft of as big of a spacecraft as you can manage. And if we had the Starship, then we could definitely launch a spacecraft of this size. You put it close to the asteroid or the comet in question, and the gravity of the object itself, even though it's minimal, because it's just a little spaceship, and yet at the same time its gravity would be sufficient to divert the course of the asteroid just just enough to where it either misses us or skips off the atmosphere. So that would be another way of handling it. But just like a kinetic penetrator, a gravity tractor system has to be ready to go at a moment's notice. We can't just have it, okay, we got delayed again. It's going to be another year, that kind of thing. It's got to be ready to go right now so that if there is, and I would say 2 or 3 of them, once again, for redundancy's sake, because rockets blow up, space is hard, or sometimes you're off target, especially when you're talking about a moving object that you just detected, so having redundancy makes a great deal of sense. If you're going to do it that way, then you have to have a system in place ready to go immediately at a moment's notice. So, important stuff, and some stuff that we're not doing, stuff that we don't care about, stuff that we don't pay any attention to. We are so concerned, for example, about North Korea and their nuclear initiative, which we should be. But I'll tell you something, and a lot of people may argue with you, but I think it is far more likely that an asteroid is going to collide with this planet inside of the next 100 to 200 years with the force of a lot of, of a nuclear weapon. It's much more likely that that's going to happen than Kim Jong-un is going to push the button, because Kim Jong-un knows that the moment he pushes the button, he's a dead man. He knows that we will retaliate and annihilate him. And any of his successors is going to know that as well. They have that stuff out there to make sure that they can remain dictators of North Korea, so they don't end up like Saddam Hussein being killed by their own people. So there's rationality there. Asteroids don't have rationality. They can't be bargained with. They can't be reasoned with. They don't have pity or remorse. They're just going to come plowing into the planet and they're not going to care. So, there's a difference between that. Yet look at all the effort we're putting in and all of the concern and all the hand wringing that we're putting into the danger of small rogue nuclear nations. I mean, granted, it is a danger. It is a danger, and it shouldn't be ignored. But at the same time, I'd say that asteroids are just as big of a danger, and yet we're doing nothing. Please by the way, please subscribe. We have over 500 people watching. Thank you so much for tuning in. I do appreciate it. Yeah, it is crazy. Oh, Elon has a plan. Let's hope so. Let's certainly hope so. By the way, I'm checking back and forth to my Discord members. It's in the description, by the way, if you want to become a Discord Patreon supporter. It's all there, and we do all kinds of things. Do I think nuclear is an option? Yes, I do, but there are some problems with that as well. If we're going to launch an ICBM, or if we're going to, for one thing, ICBMs, they're going to only explode on the surface of something, and how much they're going to divert the course of an asteroid is a big question mark. And it's hard to predict because nuclear weapons are so powerful. What's going to happen? Is it going to divert its course, or is it going to blow it into a bunch of fragments? And these fragments may not go all over the place because of the force of gravity. Eventually, all these fragments will coalesce into a big bunch of fragments, and they may still be on a course to hit us. So a nuclear weapon may not be a choice. It may be our only choice if this thing is close and we really have no choice but to take a wild shot at it, if we have no other defense. Slovenia, hello Slovenia. So yeah, there's a swarm of small, inexpensive ion drives. That's a great idea as well. Something else, in which case we take a bunch of ion drives. We use them. It's a technology that is commonly used for satellites and small probes. We take a bunch of those and land them on the surface of the asteroid or comet in question. Have them, produce just enough thrust to divert the course of the asteroid out of the way. And the nice thing about these kind of low impact solutions is we can observe how much it's diverting the course of the asteroid in real time. That makes a big difference. Thank you for the super chat, by the way. Saw that go zooming by. Really do appreciate that. But we can observe all of that. I guess it's Cynthia. Once again, I can't see this too clearly, not without scaring you guys with a close-up of my face. But anyway, so, this is another solution, the ion drives, putting them on the surface. And any of these low impact solutions, and they're the ones I prefer, slowly pushing the asteroid away bit by bit, bit by bit. I like that solution a lot more because we can observe what it's doing. It's not going to create a great big cloud of fragments that's going to go who knows where, and we can't really predict where it's going to go. That kind of solution could be disastrous. And so I would prefer that. And as far as diverting it to where, as long as it's away from us, that's all that matters. As long as it's not going to hit us, that is the only thing that matters. Thank you, Nicholas, for the yeah, nukes for this purpose is a bad idea, says Fan. I do agree, by the way, guys. I do agree. It's not necessarily a thermonuclear X-ray laser. I'm going to talk about that in a second. But yeah, in general, again, nuclear weapons are just too unpredictable. They're too powerful, and they're just going to leave, a cloud of fragments going who knows where. I would prefer something that we can observe and slowly control. And you can do that with ion engines. You can do that with gravity tractors. You can kind of do it with kinetic impactors. Excuse me. And you can do it also. And once again, my preferred method, high energy photons from lasers or reflectors, something in orbit. So anyway, there's a lot of ways to do it. I like the high energy photons just because it serves so many other purposes. Lasers in orbit would require a lot of solar panels in order to get their energy. And, if we're not using it to deflect asteroids, we can beam that energy down to Earth and use it to power our civilization, or use it to send light sails out to other stars, as has been, talked about in Breakthrough Starshot. So many purposes that this could serve besides just asteroid deflection. So it has a lot of different options, and that's why I prefer it, is just because it serves so many purposes. But at the same time, and a cloud of fragments might burn up. You're right, it might. But at the same time, if it's a 1 kilometer asteroid, how do we know it's not going to create several 100-meter fragments, which we just did an exercise in terms of how much explosive power that's going to create, a relatively small one, and that's going to make a difference. Can we use lasers to melt asteroids? Well, not asteroids, but comets. We can, as I said before, we can use the lasers to heat the surface of the comet to where it outgasses. Comets outgas anyway, but if we heat the exact right part of the comet, if we focus our energy on that, then it's going to outgas in a direction of our choosing, pushing the comet away from a collision course. So yeah, once again, I love lasers as a solution to this. The asteroid is passing by as we're speaking right now, just so you know. It can be observed via telescope. So yeah, we'll see how that works. But mining a metal rich asteroid. Yeah, if we were mining asteroids as a matter of course, I mean, not only would that be immensely valuable, not only could that bring a huge amount of wealth to our civilization, but also it would create this network of vehicles that we have out there mining asteroids that could also divert them. So that, there's a lot of solutions, but doing nothing, which is pretty much what we're doing now, aside from this one DART mission that we have. Aside from that, we are doing nothing. Oh Lord, wow! Thank you so much, Boom. I'm trying to remain conscious. Okay, well, in response to that, I'm going to go ahead and we're going to, since we have so many more people watching, over 500 people, we're going to do this again. We're going to do another collision. Let's do a realistic collision with the Earth, and I'm going to be taking votes from you guys as to what we're going to do. First of all, let's talk about, and I'm backing up, and by the way, I have this linked in the description, the Earth Impact Program put out by the Imperial College in London. Let's talk about distance from the impact first. How close do we want to be? 50 kilometers, 100 kilometers? How long away do we want to? I'm looking for votes here. How close do we want to be to the explosion? We don't want to be right on top of it because we know that it'll just kill us no matter what. In that case, 2,000 kilometers. Okay, that's a long ways. Maybe it won't do much to us at all at that distance. So yeah, 2,000 kilometers. Let's check that out. Okay, so how big do we want the object to be? Let's not make it ridiculously huge. Okay, guys, let's not make it crazy big, because if we make it more than 2 or 3 kilometers in size, it's just gonna kill us. Let's talk about something that we haven't noticed that might hit us. In other words, something smaller than 1 kilometer. Smaller than 1 kilometer. Let's go for that. And because that's what we're more likely to get hit by. All right, let's do 1 kilometer in general. Let's so in other words, 1,000 meters. That's going to be hardcore, just so you know. Okay, now what do we want it to be made out of? This is a pretty big asteroid. Do we want it ice, porous rock, dense rock, or iron? And we already did iron, just so you know. So let's do something else. Let's do something besides iron. Dense rock, porous rock, or ice. Which one do we want? Not cheese. So let's get a vote. Ice. Okay, so let's go for ice. In other words, this is a comet that we have hitting us that is 1,000 meters in diameter. So the impact velocity is going to be high because comets come in at a very high rate of speed. So it's going to be the average speed for a comet is 51 kilometers per second. That is the average speed. Let's not make it a whole lot faster than that, okay? Let's keep it somewhere in that range, 51 or 60, 40, let's keep it in that range so that it's realistic. The most common composition is porous rock from a C-class asteroid. That's the most common, unless it's a comet, in which case it's ice. So let's figure out impact. Once again, the average for a comet is 51 kilometers per second, 24 kilometers per second. Okay, let's do that. 24, so going slower than your average comet, but faster than your average asteroid, which is 17 kilometers. The impact angle, the average impact is 45 degrees. If it's much greater than that, then it's coming from a parabolic trajectory, in which case it's coming from outside our solar system, which is very unlikely. Let's try to keep this realistic. So the average angle is going to be 45 degrees. So what do we want? 50 degrees. Okay, good. Let's do that. 50 degrees. Okay. So, and do we want it to hit, I'm going to have it just for fun. Let's have it hit water for a change. So water, and we're going to have the water be 1,000 meters in depth. Okay. So let's see what happens as far as that's concerned. And we are 2,000 kilometers away. So that's a long way. So it may not be all that bad. Let's check it out. So let's calculate the effects. Okay, so we are 2,000 kilometers away. The projectile diameter is 1,000 meters. Projectile density is 1,000 kilograms per cubic meter. The impact speed is 24 kilometers per second. Impact angle is 50 degrees, and it's hitting liquid water. The energy before atmospheric entry is 36, I'm sorry, 300 and I'm messing this up. I do apologize. 36,000 megatons worth of TNT. 36,000 megatons. So the projectile starts to break up, and it hits the ground with a total force of 34,000 megatons worth of TNT. So what does this mean? The crater opens up the crater opened up in the water, has an initial diameter of 13.8 kilometers. 13.8 kilometers. And then the final crater diameter would be 4.78 kilometers because the water comes rushing in. So we have a transient crater diameter of 3.98 kilometers, final crater diameter of 4.78. So the total amount of the target vaporized, let's just have a look at the results here. So it would create an earthquake of 6.6 on the Richter scale. As far as that's concerned, the air blast would arrive approximately 1.68 hours after impact, but not terribly disastrous. The tsunami wave, not that bad actually. It's if it hits the water, it's not that bad. You're looking at a tsunami wave of about 6.7 meters. Not all that disastrous if a comet this size were to hit off the coast. And that, once again, we're saved. Well, one of the things we're saved by is the fact that it's going way slower. Now, just for fun, if it were to hit rock instead of water, so it hit the hit the ground instead, and instead, let's say we're 20 kilometers away, just for fun. But we keep the same parameters otherwise. Then what happens? We're looking, the final crater diameter would be 11.6 kilometers in diameter. 11.6 kilometers in diameter. Crazy stuff. The fireball radius would be 10.5 kilometers. And the force of the explosion would be, again, about 34,000 megatons. So again, at that distance, you're dead meat. Clothing ignites, the body suffers third-degree burns, newspaper ignites, plywood frames, deciduous trees ignite, grass ignites, and an earthquake of 7.6 on the Richter scale. It damaged great and substantial buildings with partial collapse, buildings shifted off of their foundation, serious damage to reservoirs, underground pipes broken, conspicuous cracks in the ground and alluviated areas, sand and mud ejected, earthquake fountains, sand craters, etc. Most masonry and frame structures destroyed with their foundations, some built wooden structures and bridges destroyed, serious damage to dams, dikes, embankments, large landslides, water thrown on the banks of canals, rivers, lakes, sand and mud shifted horizontally on beaches, and rails damaged after that. And by the way, the wind velocity from the distance we're talking about for a comet of this size hitting would be 1,130 meters per second, or 2,530 miles per hour at that distance, at 126 decibels worth of sound. So even, if you were 20 kilometers away from something like this impacted, you would be very, very dead. And that's not a particularly huge comet that we're talking about. And it's also hitting the Earth at a substantially slower speed than your average comet, faster than an asteroid, but still slower than a comet. So that's just to give you, again, an example of what this can do. And this link is in the description, by the way, so you can have fun with however big or small of asteroids you want to mess with. But the reason why comets are so important is because they come from the outer solar system. We don't detect them oftentimes until it's too late. We don't have enough advance warning, and that's why we need to have a deflection system in place ahead of time. And once again, the laser idea, the reason why I like it for comets is because, concentrated lasers are going to heat the surface of a comet, which is made out of ice, causing outgassing and causing it to deflect off course. It's one of the reasons why I'm a big fan of that sort of how much would the atmosphere have taken off of the asteroid? Let's have a look real quick. and this is actually a comet that we're talking about. The projectile would reach the ground in a broken condition. It would begin to break up at an altitude of 86,000 meters, just so you know, and it would hit the surface at a speed of 23.5 kilometers per second. So it actually wouldn't break up as far as that's concerned. So yeah, it's it would start to break up, but it would still hit the ground as big as it is, which again demonstrates to us why Tunguska was significantly smaller than 1,000 meters. Is, it broke up completely and air bursted with a force of about 15 to 20 megatons. Do these hypothetical occurrences have any effect on Earth's orbit? They do not. No. The only thing that would have an impact on Earth's orbit, significant anyway, is a really, really big asteroid, which would destroy all life on the surface of the planet. It's that's kind of freaking laser, freaking sharks with freaking lasers. Yeah, that's what I want. I am Dr. Evil incarnate. So yeah, that's definitely something that I would I again advocate. But there are lots of solutions we have talked about. We've talked about kinetic penetrators. We've talked about gravity tractors. We've talked about ion engines. We've even talked about nuclear weapons. So anyway, it is there are a lot of solutions here. I don't like the nukes just because they're too unpredictable, but there's so many other ways to do this, so many other ways to stop asteroids, stop comets, stop high velocity, dangerous objects from impacting the surface of our planet and endangering life on the surface. And another thing to keep in mind right now, especially the tensions between ourselves, between the United States and the People's Republic of China is very high right now, very high. And a comet or an asteroid impact that we didn't anticipate, a small one. Thank you, Johnny. Thank you very much, Johnny B. An impact of this magnitude on the surface of our planet would create a multi-megaton explosion that would have all of the characteristics of a nuclear blast, including the mushroom cloud. Now, if tensions are really high between ourselves and the Chinese, how do we know? How do we know that wouldn't create some kind of overreaction on the part of either side? Scary stuff, very scary stuff. So over 600 people watching now. Thank you so much. Please like, please subscribe. I really appreciate you guys' support. This has been a very interesting discussion. I'm going back over to my Discord supporters real quick to see what we have as far as that's concerned. Do we know if China or Russia are discussing this possibility, or is it strictly a Western world fear due to disaster movies? As far as I know, it is only, oh, thanks, Rodent, by the way. As far as I know, this is a Western world thing, but I think the Russians would be foolish, beyond foolish, not to be paying attention to this. Thank you, Carrie Ann. Thank you so much. I do appreciate that. Have it hit DC. Yeah, I can't actually determine, I can't pick targets. What you can do is you can take the megatons and then use that. There's a nuclear weapons simulator, so you could do that to simulate what kind of damage it would do to DC or something else. Does the Earth spin change as a result of smaller asteroid impacts? No, it does not. That actually shows in the program what sort of impact it has. Unless the asteroid is very, very big, it doesn't really change that much at all. So that's the deal as far as that's concerned. Okay. Rockets take off the equator to take advantage of the spin of the Earth. Oh, in terms of the results of the impact, that's an interesting question. I've never actually been asked that one. I'm not terribly. No, this is an old microphone. Just to let you know, it's a small microphone that I take along with me when I travel. I tend to travel light. Thank you, Gary. Have you seen Sanctuary on Prime that has a techno-political asteroid starship escape-like narrative? I have not actually. I'd like to check that out. Thank you for letting me know about it. I'll definitely check check it out. Phil James, on the other hand, it could also bring the planet together to fight a planetary threat. Yes, definitely. Without a doubt, it could make a big difference. Ourselves, the Russians, the Chinese, all getting together to try to defend ourselves. But once again, would it be too late? Would it be too late? How big is the asteroid going by right now? You know something? I'm going to go ahead and answer that question real quick. Bear with me for just a second here. The asteroid going by right now, and it's going by very fast, right? By the way, 124,000 kilometers per hour. It is 680 meters wide. So anything like that came crashing into us would be bad news. If you have a telescope, you can see it. Yes, if you know where to look, just pull it up online and it will check it out. So last night a comet caused a sonic boom over the UK. Did it? Another space nut. I didn't know that. Wow. As often as these things happen, they're happening all the time. Just in the past, we haven't really been able to recognize what they are. But now recently, just now we have this technology and this greater understanding that allows us to identify when these things take place. Thank you, Mars Embassy. By the way, Mars Embassy is a channel. This guy is in Boca Chica filming Starship right now. He films it all the time, every day. SN11, SN15, everything that's going to be happening, he films it. He's got much better equipment than I do, and I've used his footage a number of times in my video. Head on over to Mars Embassy and subscribe. He's trying to get to 1,000 subscribers, and I think he deserves it. I think it would be a wonderful thing. Over 600 people watching still. Thank you so much. Please like, please subscribe. But thanks for watching regardless. I really do appreciate it. Can a nuclear detonation be shaped or directed? There's some talk of that sort of thing, but once again, I'm not sure. Fragments found in Gloucester from the explosion. Really interesting stuff. Very interesting indeed. I wish it was in the UK. I'd go and start looking for that stuff. That would be fascinating. So many people gather this stuff. So anyway, yeah, that's how big it is. Once again, NASA says that it represents, the one that passes that passed us today, FO32, represents no threat to the planet at any time in the near future. But we say that sort of thing, but we don't know for certain what other objects these near-Earth asteroids are going to come into contact with, or what sort of gravitational impacts other passing bodies may have on these asteroids, because we haven't identified all of them yet. If their trajectory changes, then they could still collide with us. So, we can observe something and say, oh, it has no chance of hitting us. That's an unrealistic statement. We can't say that. We just simply cannot 100% say that. Something that comes close to our planet, we cannot say it has no chance of hitting us in the future. It could happen. Anything could change the trajectory of an object. We just don't know. And I have to admit, I am pretty scared, especially after watching watching a certain program on television recently about the possibility of future, explorers, future settlers of the solar system weaponizing asteroids. Everybody knows what I'm talking about here, or at least a lot of you probably do. Weaponizing asteroids and using them to pummel the Earth and pummel our civilization here, and sort of like terrorists would. That's a scary thought, and one of the reasons why there's an urgent need for asteroid deflection. Who knows if somebody's going to intentionally send one of these things our way someday. As precisely as this sort of stuff can be controlled, once we have a lot of human presence in the solar system, there's a lot that could be manipulated. Could we latch on to an asteroid and examine it? We have actually to some degree already, but still we have a lot to learn. We've done sample return missions from asteroids and comets, so a great deal. Thank you, Timothy. The Green Run episode, yeah, I did that. I pulled just about the only good footage I got off of that and put it into that episode, but it was amazing to watch, let me tell you. Amazing stuff. Very, very cool. So yeah, and that's true what was just said. Anything with any mass is going to have an impact on other celestial bodies, and who knows what's going to be directed. Anyone done the Bruce Willis joke? Yeah. Armageddon is one of my least favorite movies that has ever been made. Deep Impact came out the same year, was a pretty damn accurate depiction of what, the consequences of a comet plunging towards our planet would be. But at the same time, then we had Armageddon come out that year, and it pulled way more viewers, and it was garbage. There's no way that an asteroid of that size could have been diverted in time. It would have utterly destroyed all life on the surface of the planet without any chance of diverting it. I don't care what kind of nukes you threw at it, or if you throw Bruce Willis at it, it's not going to be enough. I watched that whole thing in the theater, hating every minute of it except for the joke parts, but the rest of it was quite annoying. So anyway, let's have a look here, and just see if anybody. There it is. There's a link that another space nut put on our Discord server for the meteor said to have caused a sonic boom over Devon. Very interesting. So Devon, Somerset, and Dorset, all of which I've been to a number of times. So some kind of sonic boom created by a meteor. Very interesting indeed. We should punt that bad boy out of the way and mine the freak out of it. Yes, especially if it's a useful asteroid. Absolutely, mining it would be a much better solution than getting hit by it. So yeah, we've had some opportunities to talk about solutions. We've done a couple of. Thank you for subscribing to Mars Embassy, by the way. We have some other folks that have talked about solutions, and we've done a couple of exercises in seeing what an impact would do, what the long-term consequences would be. And I'll tell you, that website is sobering. It really is. And it's not something that somebody just made up. It is from the Imperial College in London. It's a really reliable site that provides very good scientific data. Grew up in the 1980s. Everyone was making Tunguska rather famous. Yes, Carl Sagan's Cosmos, they had an episode about that. He's the one actually who also talked about how asteroid impacts create nuclear appearing explosions, including the mushroom cloud. And given how tense things were between us and the Soviet Union in those days, it was a real serious threat, that could have caused a nuclear conflict. Thank God nothing that happened. Thank God nothing that happened. Or rather, nothing happened during that time. So anyway, apart from the Eminem and Liv Tyler's navel. Yes, I suppose that was a good part. Yeah, it's been forever since I've even seen that movie. I hate it so much. Deep Impact, though, love Deep Impact. That's a fantastic movie. Definitely a big fan of that. So I'm at a stage where I'm going to be wrapping up fairly soon, simply because I have a video to complete. I'm doing a video about another object that hurtled through our solar system not that long ago, an object that has been the subject of intense debate and speculation. Thank you very much. Everybody's saying that they love my channel. It's so nice of you. But this is something that I'm going to be releasing today is my goal. So I need to get back to work on it. I've accomplished a fair amount with it, but it's based on some stuff that's come out very recently about this object, some new theories about it that I want to talk about. Yes, Oumuamua, good guess indeed. So yeah, I'll be talking about that and about a book that was released this year about that particular subject, and it is very convincing, very, very convincing. So I'm going to be putting all of the proof out in front of you guys, and then you make your own decisions. So until we have a reliable system in place to defend this planet and the future of our civilization from this very real, this very present threat to our species and to our civilization, until we finally get our heads out of our collective asses and finally do something about this in order to protect ourselves, our children, our families, our civilization from this sort of danger, I urge all of you to stay angry about space.